Hello. This is the final video I'm doing on reviewing the Tuition Center papers from 2025, at least the mock papers, and this is the one on physics. So I reviewed both the maths papers and the applied maths papers, so now I'm moving on to physics. It's the last one that I do. I know they do accounting and chemistry and biology or whatever, but I don't do them. So I'm only doing the ones that I have pretty much experience with. So I mean, well, first thing, like section C is in the question paper. Okay, right. Normally in physics, you answer everything on a question paper. Like you can take your papers home with you. So odd decision. Let's see what happens. Okay, yeah. First things first. I'm seeing is that this one's not following the standard SEC format that the rest of them have. Firstly, there's no place to put your calculator in there, so that's a start. Conservation of momentum. Yeah, I mean it hasn't come up in quite a while, but again, to travel a distance, fine. But also no spacing with the units. That's standard to space the units out. But then also no subscription the time. Okay, yeah, I think definitely the next video I'm going to make is something about the equation editor. Use data, verify momentum. That's fine. I mean, usually this is like the last thing they ask, or one of the last things, and then they'll ask you a safety question. So, they might usually ask you these first, then the conservation of momentum, then all your precautions and accuracies. So, in terms of question format, not necessarily that great. Well, it's not actually going to be applicable now for the new courses coming in, but for the people sitting at this year, like they're not going to ask you like this, as far as I can remember from all the physics papers that I've done. Okay, this is Schnell's law. It's fine. I mean, not really predicted one for the fact that we had a lenses question in last year's papers, so they're unlikely to do refraction twice. But okay, draw a suitable graph. Again, usually one of the last things they ask you is to draw a graph. And for 21 marks is a lot. That's so many marks. From the graph, determine refractive index. Yep, but again, 10 marks for that. A lot of these just seem pretty steep. Explain how the position of refractive ray was found. Yeah. Okay. Right, question 3 first. Water. Again, I think that was what was asked last year, and they're not known for repeating experiments. I could be entirely mistaken. It might have been fusion, but something akin to heat. But they have been adding it in pretty much every exam, so it might just be a new thing. Draw a label diagram. 6 marks for diagrams, not a lot. Give the equation which one of these calculate specific. Not even ask you to calculate it. Just give the equation. That's never going to be asked. You will always be asked to calculate it. There's going to be calculation somewhere, like either calculating or graph drawing. Like there's no way of getting out of that in section A. Precaution, mass esteem determined. Yeah, it just seems a bit all over the place in terms of marks, really. Question 4: natural frequency and its length, constant force. Yep. Draw a suitable graph on graph. A suitable graph of graph paper. I have to say I didn't actually look at the errata on this, so I'm probably gonna have a look at it after, just to see how many mistakes I've actually missed in here as well. But I've seen a couple here. Relationship graph verifies it. Yeah, as frequency goes up, the length goes down. Yeah, because it's 1/2Ls. Yeah, as f goes up, L has to go down as a result. Okay. Ooh, what's going on here? Why the sudden font change? I mean, it's a bit okay. Resistivity of nichrome. Again, didn't that come up last year? I swear that came up last year. Or am I tripping? Okay, whatever. I'll trust them, don't worry. Experiment several of these micrometer reading were taken. Reading of the micrometer is that. Resistivity of nichrome. Yeah. I will say that is actually a nice question, talking about accuracy. It's not really something that a lot of teachers talk about, but it's important to consider experimental errors and such. So, yeah, that's the end of section A. I think overall, like, mediocre at best. Like, there's not really a lot asked, essentially, if that makes sense. The marks were kind of not distributed very fairly. So there's one which is 24 marks. Usually there's like 5 or 6 parts in a question that are kind of split up, at least semi-evenly. Like, some of the calculations are going to get more marks, obviously, but they're usually split into a lot fewer marks, or more sections with fewer marks instead of small sections with big marks. Like, it just seems a tad intimidating to stick a 24 next to one question. So that's how I'm doing it. Also, hang on, is that 42? Yeah, 24 9 is 33 9 is 42 marks. Okay. Are there any other maths errors on this? 28 at 12 is 40. 6 9 is 15, 30 is 40. 29 is 40, yeah. 16 and 18 makes 34 and 6 is 40. Yeah, okay. So they've messed up the marks, okay. Ah, that's why. Ever since 2003, this hasn't been the format of the physics paper. The question 6 was just a bunch of questions in order in your answer book. It hasn't been like this since the course last changed, as I said, which I think was in about 2003, maybe 2004. So before, this used to be the thing. You hand out the answer booklet as well as something like this, where you write down A, B, C, D, E, etc. I've done these reviews. I've done 3 of the reviews now, and I'm actually starting to doubt whether people like these exams or not. It's good for extra study, but it doesn't reflect the state of the Leaving Cert. Like, it really doesn't. I mean, unless it changes for this exam year, which I don't think it should. I really don't think it should. It's probably going to change for next year for the fact that you now have square grids. That was from the sample paper that they put up. But it's not going to be like this, I don't think. And if it is, oh well. Unit of energy, the joule. Yeah, again, not really something a lot of students pay attention to in the decomposition of units. Simple harmonic motion described by that. Again, please use the equation editor. Natural frequency of a string. Yeah, like, it's best to let students write their own answer instead of giving them all these answers. You could ask, list, 2 quantities which can vary the fundamental frequency of a string, instead of saying the natural frequency of a string is just a bunch of different proportional things. And again, there's stuff out of order here as well. It usually goes in order of the course. So you have your mechanics stuff at the top, usually questions A through C, maybe A through D. Then you have your sound and light stuff, then your electricity, then your modern physics, and then your option at the end. But here, they're putting things out of order, which is unusual. This would probably be like a question J or K, I would nearly think. Not a question D. Question D, you might see a sound question as question D, not a nuclear fusion question. Define temperature in Celsius scale, okay. Alright, again, just say sketchograph instead of using the axes. Like, it just has to be realistic. Also, is that a 0? That's meant to be a theta, but sure. Yeah, and again, there's resistance, then there's transformers, and then there's that, and then angle of declination. Like, everything just seems to be all over the place. But also, there's 12 questions, not 11. As far as I remember, you get 12 to choose from, not 11. Unless I'm mistaking something, and I think I probably am. But yeah, you get 12 to choose from instead of 11. That's what I checked. Right, define displacement, acceleration. Yep, okay, body's traveling. Again, equation editor. This is not a valid equation. car accelerates uniformly from rest to what is it with these teachers including applied maths questions in subjects which aren't applied maths? I know this is linear motion, but like still it just has the essence of applied maths essentially. Oh, I remember this question actually. One student sent me something very similar to this. Did this appear in another mock or something? Because I think it did. Because one of the students that I tutor sent me basically this exact question. Okay. I mean, I guess it's fair for the fact that this one's only 4 marks. It is just the fact that it's a distance speed time calculation. For the fact that the horizontal velocity doesn't change if we're assuming no air resistance. I mean, it doesn't directly say, but you can assume it has no air resistance. Plus, why is the beginning of question 8 here? That's weird. Okay, state briefly how maybe sunlight may be polarized. Again, probably best to ask what is polarization and then such and such, instead of asking straight up, you know, how can light be polarized? It seems a very sort of in your face type question. So, you know, it's always better to ease people in instead of giving them essentially like a level 4 Bloom's question, essentially. Comment on the historical significance of the experiment. Okay, that's a fine question I haven't actually seen before. Probably apparatus labeled O. What is this function? Yeah, it's double slit. Let's see what was observed on the screen. Okay. How may it be shown that really? Okay, I know these people do physics, but they should know how a question mark works. Transpacific diagonal frequency of the note needs to be higher. Yeah, standard Doppler effect question, but 12 marks a piece. I think is again pretty steep. Also, are these 56? 12, 24, 30, 48 at 8. Yeah, okay. Thankfully that one's 56. Okay, another specific capacity, specific latent heat. Okay, saucepan is what okay, it's fine. It's just talking about heat transfer basically. Given the volume of air in the kitchen is that, and the water is evaporating from the saucepan at a rate of that, calculate the rate at which energy is transferred from the water in the saucepan by evaporation. Okay, I mean, not an impossible question, just a bit of an odd one. The rise in temperature of the air caused by the evaporation in 5 minutes, assuming that 10% of the transferred energy is absorbed by the air. Okay. Again, as well, I know I'm being picky, but 2.3 times 106. Some people could get confused by that and think that that is genuinely whatever 2.3 times 106 is, which is 243.8. I know it means exponential, but you have to be specific and not mislead people. Ooh. Seems these. Okay, this is a very short question. What's going on here? Use diagrams to raise parallel principal axis by concave convex mirror. Okay. Focal length of concave mirror. Okay. Oh, parallel. Okay, so this one's just asking essentially this, but with another ray. Okay. Right. I mean, this question here definitely needs a bit more. I don't think that like that many parts would warrant a full question. I really don't think so. But I think we found our first fine question. It seems a very standard, like maybe 75% of a full mirrors question. You know, they might do what they did in one of the deferred papers, and they might say if a student used a lens, what might happen, or what lens kind of goes with, or what lens behaves like what mirror, for example. Just trying to be sort of different with the questions, essentially. But I think that's fine, at least enough the way it is. Physics. Yeah, fine first 4 parts for modern physics type stuff. 6 tera electron volts. Yeah. Again, standard particle physics collision type stuff, but wait, that's a lot of parts. What? Oh, they're just like little staging things. Okay, I thought there was a lot more to it. Sigma particles made up of enough quark, down quark, and a strange quark. Yeah, just differentiate between mesons and baryons there. And then talking about the... I mean, I've never actually heard it called a sigma particle. I call it a sigmon, but I've never heard it be called a sigma particle. Okay, a particular K1 is a down quark and an anti-strange. So, yeah, essentially the same questions, but for the K1. Okay, there's actually a lot of stuff here. Okay. Engine is CERN. Yep. BQMNR. Yeah. This is like the inverse of the previous questions. There's a lot of parts here. But I think they're short enough where it might only take up maybe 2.5 pages max of writing and working. So I'm content enough with that question as it stands. One law of electric, define magnetic flux. Something Faraday's law. And then this is something Lenz's law. Oh, what's got on here? Have they stolen another question? Ooh. Yeah, I mean, they've literally just copied a question, put it over the question number, and talked about Röntgen rays, which is what I believe people in Germany call X-rays, just for the fact that you discover them. But it seems a very like okay enough comprehension question. Fluorescence, I think people would know, but I don't think it's specified on the course. I'll have a double check. And just as well, I'll put erratas in the pinned comments just in case I do make an error, because I am human as well. But I'm just giving comments on this. Yeah, again, just equation editor. Okay, question 14. Is there a mechanics bit in this? Okay, there is, but mechanics is always 14 part A. I can't remember a year where mechanics wasn't a 14 part A. So again, you really have to focus on getting the format correct if it wants to be considered a good mock exam. Because if it's not in the right format, then what's the point? Yeah, it's fine. Radioactivity. Again, I'm not going to say the same errors again. Dispersion and total define the what terms are underlined. I assume dispersion and total internal reflection are the two terms, but if they're not underlined, then how are students going to know? And again, just like taking a diagram from, I presume, a mock from 1812. Yeah, I mean, interesting enough question, you know. Adding, if you're slowly adding water to it, can change the mass and the turning effect. But again, if you're including stuff in relation to hydro stuff, can't think of the word, fluid mechanics and dynamics, probably best to include something. So then what happens if a student, say, drops a, I don't know, if they decide to put their fingers in it or something, what's going to happen? Or if they drop a cube in it, what's going to happen? So it might be good to include some stuff there, because I know that fluid stuff can also be a bit of a challenge for some students. And yeah, that's the end of the paper. Okay. Again, I'm really discontent with this. There's definitely a lot of areas for improvement for pretty much all the papers. Like, I know no paper is perfect, but there's areas in which pretty much all the papers can be improved. So even in the maths papers, it seemed a lot of the diagrams were the owner's original diagrams. So there's kind of no excuse for the other teachers not to get on board. Even just asking, say, how would you do this diagram, or even what software they use, is probably not a bad shout instead of taking diagrams from old exam papers. That's just not the way to go about it. So hopefully all these reviews have helped somewhat, and I wish everyone best of luck in their Leaving Cert exams.